Okay, guys, let's finish this lesson by doing a real world exponential equation example, guys. Okay, so we could just kind of look at this, guys, and go through it as much as we can. We find that they give us a formula right about here. You can tell right away. They give us this formula, and then they're going to ask us to substitute for g in there, put 32 in there. So 32 goes in here for g. And the 64 feet per second will be the weight, velocity that we need to find that there, guys. So let us just work through that. So what we have right there, guys, is key here is a problem in which we're going to solve something like this, in which we have 64 equal to the radical of 2, the radical 32 there. Okay, so what do we do here, guys? How do we solve the problem like this? So let me see if I can make this just a little bit bigger. Okay, so we have something like this. As you can see, I'm going to show you a cool way of also doing this, and then I'm going to explain the one in the book. If you can see, whenever you have a square root, guys, especially for geometry, when we did a squared plus b squared equals c squared in algebra and pre-algebra, we always took the square root of that. Okay, so in here they want you to take care of the exponents. So we're going to look at 32 versus 64, and we're going to see what they have in common here. Okay, and let's see if we can put this in exponents and then figure it out if we can do it later. So you can see right here, guys, that perhaps we can rewrite this with exponents, a to the second. And 32, guys, would be maybe by twos, right? No, not by fours, because four that will give us 64. No, not by threes, that would be 27 and 81. So 2, this will be equal to 2 to the fifth power, guys, because 2 times 2 times 2 times 2 times 2, that's 4, 8, 16, 32. This would be 32. So it's 2 to the fifth. So what can we do with that, guys? Well, they're not the same. So what do we do? How do we solve that? Okay. And that's okay. We got this. Okay. We got this. The key is that we got this and we got that. Okay. So we go back to, we can see we have this right there. And we get that one right about there, guys. Okay. So the key here also to understand that if we have the square root, a square root of, let me see, what do we have a square root? If you ever have a square root, guys, let's say 4, you know the answer for that. But that's the same thing as 4 to the 1/2. Okay. See, let me show you that in the calculator so you can see it. And it's just key, you guys, for us to understand a lot of stuff like this. Okay, let me go here, here. So if I was to take just the square root of 4, guys, if I was to take the square root of 4, you will know that is 2. Okay. But what if I took that same 4 and I put it to the power of 1/2? Okay, I'm going to put it to the power of 0.5 or 1/2. Okay, the answer is 2. See? So anything, because this is a 2 right there, that will be to the 1/2, it will give us that. So let me rewrite it a different way. So if I was to go 4 to the power of, and then I'm going to open a little parenthesis, guys, and I'll put 1 divided by 2. 1 divided by 2. That's the same thing as 0.5. Okay, and look, it's 2. Okay. So when you take the square roots, like if we're going to talk about cube roots later on and 4 roots and all that kind of stuff, guys, you're going to see that that is equal to the 1/2. Okay, so and going back to this, then we realize that we can have something really, really cool here. We take that and we say, okay, I'm going to See how they went to the 1/2 right there, and they're going to go to the 1/2 right about here. And let me see if I can get that. Okay, let me see if I can go. Let me see if I can erase that. My apologies, guys. And go here. Okay. All right. So we said 8 to the second power is the same thing as, and 2 to the fifth power, r, and I'm going um, to the 1/2. Okay. And I would like to see if you can, if you guys can see this. And let me see if I put it right there. And to get rid of this, the square root right there, guys, I'm going to square both sides. I'm going to square both sides. So then I'm going to end up with 8 to the 4th. See that? And here I end up with 2 to the 5th right there. Then r. Okay. There's nothing else to do from there. And then once I have that, you say, oh my gosh, look at this. Now 8 is equal to 2 to the third power. See that? Yeah. So I'm going to go, okay, I got that to the fourth power equals to 2 to the fifth power r. Okay. And I'm going to put 8. No, that would be 2. Well, you know what? I don't, yeah, 2 to the third power. So what I have here, guys, it will be 2 to the seventh power. Can you see it? No, to the 12th power right there. Okay. I'm getting ahead of myself right there. Okay. Now I'm going to divide both sides by, and I'm going to find r. 2 to the fifth. 2 to the fifth. Okay. And that will give me r. Now, please remember that this is the same thing as 12. And I'm going to subtract 5. So I'm going to get 2 to the 7th. So the answer will be 2 to the 7th. That's another way of doing it, guys. As you can see, once we got this, it's better to go this. That's another way of doing it. And 2 to the 7th power, if we go here, it will be 128. So r equals to 128. Because 2 to the 2 times 2 times 2 times 2, that will be 64. 64 times 2 will be 128. And here, what they did is they took the square root to both sides, guys, and they ended up with a um, uh, 8 to the here we ended up with 8 to the 4th. This was 8 to the 4th, and then they divided both sides by 32, and of course they got we got 32r right there, and then we divided everything by 32, and you got 128. Okay. I hope this was not confusing, guys. This way and the other way, and you can see I wanted to keep the exponents. I made it. They were not equal, and then until they were, and then I was able to just divide and then get the same answer. I hope that was helpful and not confused, guys. Okay, but I really liked how they did it here as well.